Imagine drifting through the endless void of space, unattached to any star, just floating in solitude. These are rogue planets, mysterious celestial wanderers that roam freely, completely unbound to the sun or any other star. Some of them are leftover remnants from former planetary systems, while others might be strange objects captured by gravity. Now, let's dive into the intriguing hunt for Planet X, that elusive big planet lurking beyond Neptune. Even after we discovered Pluto, many astronomers are convinced there are still hidden giants waiting to be found in that icy expanse of our outer solar system. It's like looking for treasure in a cosmic sea. Picture this. Simulations suggest that some massive planets could have escaped the sun's grasp when our solar system was being formed. They might have drifted all the way out to the mysterious Oort cloud. Could this be the reason for the existence of those rogue planets? It's a wild thought. Speaking of cosmic transformations, take a look at red dwarf stars, like Koi 55. They reveal just how dramatically stars evolve over time, creating hotter environments that drastically change the orbits and climates of nearby planets. It's like a cosmic makeover that has massive repercussions for their planetary neighbors. Now, Koi 55b is a real heat champion. With temperatures soaring to a sizzling 12,000 degrees Fahrenheit, this planet has adapted to some seriously extreme conditions. This makes us rethink what it means for a planet to be habitable and if life could survive in such fiery places. But not all planets are so lucky. Let's talk about WASP 12b, which is facing a dramatic end due to being way too close to its star. Its impending doom stands in stark contrast to the survival of Koi 55b, showcasing the wide variety of destinies planets can face depending on their star relationships. As we gaze into the dark void of space, it's not just emptiness. There's dark energy at work, influencing how the universe expands and takes shape. This mysterious force is a hot topic among scientists who are digging into its secrets. And then there's the Goldilocks zone, that sweet spot around stars where conditions are just right for liquid water, a must-have for life. This concept is crucial for astronomers as they hunt for other planets that might support life, shooting for those perfect conditions. However, Europa, one of Jupiter's icy moons, flips the script on habitability. Even though it's hanging out outside the Goldilocks zone, it keeps warm due to tidal forces at play. This raises some mind-bending questions about how adaptable life could be in such extreme climates. Now, let's fast forward to Theta C, a massive star expected to burst into a supernova in about 1 million years. This cosmic event is part of the never-ending cycle of star birth and destruction that shapes our universe. In our video, we explore how gravitational interactions between dwarf galaxies and the Milky Way lead to fascinating processes like accretion and gas stripping. These activities play a crucial role in how stars are formed, showing us the dynamic dance of the cosmos. And then there's the Tarantula Nebula, a super dynamic hub of star formation within the Large Magellanic Cloud. It's home to the R136 star cluster, featuring some of the most massive stars in the universe. It's like a cosmic factory churning out new stars. Now, let's talk about the transit phenomenon, where planets pass in front of their stars. This exciting occurrence gives us crucial insights into their atmospheres and whether they could potentially harbor life. It's been a game changer in the search for exoplanets. Speaking of exoplanets, star systems like TRAPPIST-1 are packed with multiple worlds hanging out in habitable zones. This raises our hopes of finding extraterrestrial life as we analyze these fascinating systems. Let's not forget about the Voyager probes, our messengers in space. They carry messages from humanity, hoping to connect with alien civilizations. These probes are like time capsules, containing sounds and images that represent life on Earth, reaching out into the unknown. Recently, we discovered LP890-9b, a planet that weighs about 13 times more than Earth and zooms around its star in just 3 days. That's some seriously rapid movement. But what does that mean for its extreme seasonal changes? Now, here's the kicker. LP890-9c is hanging out in the habitable zone and might just have what it takes to support liquid water. This makes it a prime candidate for atmospheric studies, especially with the James Webb Space Telescope joining the party. But don't get too excited just yet. LP 890-9c has to deal with challenges like high radiation and tidal locking, which could seriously impact its climate and atmosphere, making it less friendly for life. And speaking of challenges, the moon might not have a significant atmosphere, but it does hold some trace amounts of oxygen thanks to Earth's upper atmosphere. This little bit of oxygen plays a surprising role in the moon's geological processes. Then there's Uranus, with its wild tilt of about 98 degrees. This unusual tilt creates crazy long seasons that last around 21 Earth years, dramatically affecting its climate and seasonal experiences. Talk about taking your time. Now, closer to home, Mars has two moons, Phobos and Deimos. But here's a wild prediction. One day, Phobos could get torn apart by Mars' gravity. This could lead to an awesome transformation, creating a ring around the red planet. And what about those bright blue bursts we hear about? They're considered some of the most magnificent optical phenomena in the universe, sparking curiosity about what powers them. Scientists are on a mission to uncover the secrets of their radiance. Theories suggest that these bursts could originate from stellar remnants, like neutron stars or black holes, producing emissions at nearly light speed. It opens up an exciting frontier for understanding the universe. In a twist, we also discover unusual explosions, like the Finch phenomenon that pops up outside of galaxies. This raises eyebrows and challenges existing theories, hinting that we might need new models to explain these cosmic fireworks. And when it comes to housing on Saturn, it's all about being low profile and aerodynamic to withstand those fierce winds. Plus, using sturdy materials to prevent damage is crucial. Wind-powered turbines? Yes, please. They'll help supply all the energy needed. Now, Europa is a whole other story. With its icy surface, we'd need to build underground habitats to tap into the warmth and fresh water of its hidden ocean underneath. Insulation and water purification systems would be a must-have to survive there. And on Pluto, we would need a greenhouse dome to create a livable environment. This dome would utilize sunlight-enhancing panels and systems for water and air generation to support life in those chilly conditions. Let's clear up a common misconception about black holes. They don't actively chase after objects. Instead, they wait patiently until something crosses a certain threshold. This passive waiting game is often misunderstood, but it's crucial to grasp. Here's a surprising fact. If our sun were to be replaced by a black hole of the same mass, Earth wouldn't feel a thing gravitationally. This highlights the importance of mass over the characteristics of a black hole itself. And what about microgravity on the International Space Station? It's often confused with zero gravity, but it's actually 10% weaker than what we experience on Earth. Astronauts float around in a free-fall experience, creating that magical sensation of weightlessness. But keep in mind, astronauts need to exercise regularly to combat muscle atrophy from the lack of gravity in space. They've got to keep their muscles strong and healthy, ensuring they can handle their time up there. And get this, space has a unique aroma, reminiscent of burnt steak or barbecue sauce, thanks to hydrocarbons floating around. But astronauts can only savor this smell when they take off their helmets in a space vehicle. Talk about a cosmic cooking experience. As we look ahead, a nova event is on the horizon, like the one with T Corona Borealis. It's a dramatic explosion on a star surface, and while it doesn't destroy the star, it's an observable event that happens regularly from our vantage point on Earth. The universe is an enormous place, filled with billions of galaxies, yet supernovae are pretty rare. We only see a handful in the Milky Way each century, while astronomers spot hundreds beyond our galaxy every year. It's a cosmic rarity, worth celebrating. And then there's Betelgeuse, the massive red giant star that might one day put on a spectacular supernova show for us here on Earth. But its recent dimming in 2019 has left astronomers wondering if it's gearing up for that explosive moment or just taking a little nap. But hold on to your hats, because Earth's magnetic field is also weakening, which could expose satellites and electronics to cosmic rays. Ongoing studies aim to understand what's happening and how this affects us, piecing together the historical context through geological evidence. And as we ponder our own sun, there's speculation that it might lose a significant portion of its mass over time, potentially sparing the Earth and the Moon from total annihilation. This is still a theoretical idea, leaving us all curious about our cosmic fate. Finally, let's wrap up with the mind-blowing age of the universe, currently about 13.77 billion years old. But one day, it will stop creating new stars. After around a trillion years, only the last red dwarf will be born, marking the end of an era. And in about 100 trillion years, the last light in the universe will flicker out, leading to a dark and lonely cosmos. Thankfully, we humans won't have to witness that end, allowing us to focus on the wonders of the universe while we still can.